All right, this video is for lesson 7.5, which is about exponential functions. All right, there's two things that we're going to focus on here. One is to be able to graph an exponential function. All right, and the second thing that we're going to focus on a little bit is how to look at a table of values and determine whether a function is exponential or not. Okay, so with an exponential function, you're going to be dealing with an equation that is in the form y equals a times b to the x. All right, now this power, notice, is x. That's where our variable is going to be. So let's jump right in and kind of walk you through how to do this. Okay, they want me to graph the equation y equals 3 to the x. Anytime that I am asked to graph and I'm unsure of how to do things, I always start off with a t-chart. And what I'm going to do is plug different values in to see what I get. All right? I always start by plugging in 0. So if I plug a 0 in here for x, I get 3 to the 0 power. Well, any number raised to the 0 power gives me an output of 1. All right? I'm going to try another number. What if I plug a 1 in? Well, that would give me 3 to the first. 3 to the first is 3. I'm going to plug another positive number in, I get 2. That gives me 3 squared. 3 squared is 9. Now I'm going to try some negative numbers as well. What if I plug an x in that is negative? Well, 3 to the negative x power, remember 3 to the negative x, to get rid of that negative exponent, you move that value, that base. So this becomes 1 over 3. When x is negative 2, I have 3 to the negative second, which would be 1 over 3 to the second, or 1 over 9. Okay? So I have these different points right here. Now I'm going to go to a coordinate plane, and I'm just going to start sketching them to see what this thing is going to start to look like. Okay? So when x is 0, I have a y value of 1. So right there, I'm going to put a dot. When x is 1, I have a y value of 1, 2, 3. So I'm going to put a dot right about there. When x is 2, y is at 9. Well, that's going to be 4, 5, 6, 7, 8, 9. That's all of a sudden going to be way up here. All right? If you look at the dots that I have so far, I'm noticing a little bit of a curve that's starting to happen. Well, when I have x is negative 1, I'm at 1/3. When x is negative 2, I'm at 1/9. So this thing gets really, really close to the x-axis. Let me go ahead and change colors here, just so you can see it. It's really, really close to the x-axis, and then it starts to curve up. And this is known as an exponential curve. This in particular is called exponential growth. And the reason why it's called growth is because that 3 is greater than 1. So growth means greater than 1. If you think about it from left to right, this graph is growing. All right, so let's take a look at another one here. Excuse me, I needed a drink. All right. I have x, y. So I'm going to start off because I'm not really sure what this is going to look like. Plug in a 0. Well, at 0, 1/4 to the 0 power is 1. Again, remember we're using this equation right here. So what if I plug a 1 in? Well, if I plug a 1 in, 1/4 to the first is 1/4. How about a 2? Well, 1/4 squared is 1 times 1, or 1, and 4 times 4 is 16. Wow, that's getting really close to y being 0. All right, let's see what happens when I plug a negative 1 in. Well, negative 1 is going to flip this, right? So negative 1/4 to the negative first power is really 4. Negative 2, if I plug that in, 1/4 to the negative second power is really 16. All right, and that I know because I understand my rules for exponents. All right, so I'm going to graph a coordinate plane here. First thing I'm always going to do is start with that 0. So I know I have a point here at 0, 1. All right, that's my y-intercept as well. Okay, now when I graph this, I have 1, 1/4. So I know that this graph is approaching, when I graph 2 and 1/16, I know that this graph is approaching the x-axis. All right, what happens to the left? Well, at -1, I have 1, 2, 3, 4. Holy cow, all of a sudden it starts to go uphill really fast. And at -2, I'm way up, somewhere up here, I'm just going to estimate it at 16. So that leaves me with a curve that looks something like this. I know my graph's not perfect because I can't draw perfectly, but it gets really, really close to this x-axis, and it never again passes through it. This is something that is known as decay. Now, decay occurs when that value raised to the power is between 0 and 1. All right, so we've graphed these two functions now. Now let's go back and see what else they wanted us to identify. They want us to identify the y-intercept. Remember, the y-intercept is always going to be when x is equal to 0. So we have a y-intercept here at 0, 1. They want us to identify the domain. The domain is all real numbers unless there's something called a restriction. And remember, domain refers to the x's. I can plug any x in that I want. That's what the arrows on my graph are showing me. So then the domain would be all real numbers. The range is my output, or my y values. Now, this graph does not pass below the x-axis. Therefore, I would say that my range is y's have to be greater than 0. All right, let's take a look at the other one, the decay graph. So for decay, my y-intercept, again, all I got to do is look, what's happening when x is equal to 0? I have 0, 1. The domain is my x's. I have an arrow going in both directions. There's an arrow there. So I know my domain is all real. My range is again restricted because this graph comes down, but it never, no matter how large of an x I plug into that power, it's never going to get to 0. It'll get really, really close to 0, but it'll never get to 0. So I know that the y's always have to be greater than 0. All right, so the second thing in this lesson that we want to be able to do is to be able to look at a set of points. Now, they have these points organized horizontally. I did my points up here vertically. Whether it's vertical or horizontal, it doesn't matter. What you want to do is you want to look at the pattern that y is telling you. All right? If you add or subtract by a constant, then that means that the graph is linear, or it's a line. If you multiply or divide, again by something that is constant, the exact same value from one term to another, then that is describing something that is called exponential. All right? So if I look here, I know to go from 64 to 32, I could either multiply by 1/2 or divide by 2. Now, 32 to 16 is also division by 2. 16 to 8. I'm dividing by 2. 8 to 4. I'm dividing by 2. 4 to 2. I'm dividing by 2. All right? Because of this specific tendency right here, we can now say that this set of points represents an exponential function. All right? I hope this helps. Good luck. Let me know if you have any questions.